All right. Good morning, everyone. This is Clay Trawernick here at University of Hawaii Cooperative Extension. I think we're going to get started here. Very happy to have Derek Wroe from National Weather Service sitting next to me in my office, and glad that folks were able to attend. I'm just going to start off with an overview of kind of what the program is for providing this to everybody, and then we'll turn things over to Derek. And I just wanted to say, for those of you that aren't familiar with the webinar setup or this particular GoToWebinar, you guys should have the ability to kind of raise your hand. You're all muted at the moment, but you have the ability to raise your hand. And I was talking with Derek, feel free to raise your hand with questions. You can either type them in or I can actually unmute you and you can ask your question directly. So at any time during the presentation, if you have a question, I'll be kind of monitoring folks through our little attendee list here, okay? So I'm going to get started. First of all, Joint Fire Science Program has made this all possible. So this is a federal program with funded primarily through the Bureau of Land Management and U.S. Forest Service, and they're really in the business of doing fire science to support sound decisions. And where the Pacific Fire Exchange falls on is the kind of decision-making part. And so they've created this fire science exchange network across the country now, which is really designed to put the best information in the hands of managers and practitioners on the ground. It's also to make sure that the science that's being done is meeting their needs. So it's really all about this two-way communication. Here in the Pacific, we have the Pacific Fire Exchange is sort of our regional knowledge exchange network, and it's founded by the Hawaii Wildfire Management Organization, U.S. Forest Service, Institute of Pacific Island Forestry, and of course, the University of Hawaii Cooperative Extension. And so we've been sort of functional since about 2012, and we've been really hitting the ground running over the past few years, doing webinars, fact sheets, and things like this. So our goal really is to reduce wildfire threats to ecosystems and communities. And the way that we do that is facilitating knowledge exchange. So kind of that, again, that two-way exchange between researchers and practitioners, trying to enable collaborative relationships where we can, and then leveraging the best available science to answer folks' questions. And in addition to webinars, which you guys are participating today, do field trips, workshops, fact sheets, and research briefs, all of which can be found on our website, which is listed below, pacificfireexchange.org, and follow us on Twitter. We're active on social media. And one last thing, before I turn things over to Derek, we have a survey. There'll be a link for the survey at the end of the webinar that I think gets sent directly to you guys. And please fill it out. Take a couple minutes. It's not long. It helps us do our job better. So appreciate everyone's participation, and I'm going to turn it over to Derek Wroe.
Hi everyone. Thanks for tuning in. It's a real pleasure to be able to do this, and it's been nice meeting Clay. We've worked together in the last few years, so it's kind of nice to see sort of on the weather side a lot of things. Work that we do in the National Weather Service, you're sort of insulated in the office, and you never really get to hear how it's being used out in the field. So it's been really fantastic to get together with Clay to kind of put that perspective in there to see what we're doing and how people use the data. And I'm kind of interested to hear what you folks think. And this is just here to sort of show you what we look at and sort of how you can help you understand sort of the climate of Hawaii and how that sort of fits into how things work here. So just to show you a little bit about who I am. My name is Derek Wroe. I'm a senior forecaster there. I'm also an incident meteorologist. For those of you who don't know what that is, it's a small subgroup of forecasters in the National Weather Service that are qualified to go out on wildfires and be sort of what we could say is the weather guy on the fire. I started out here at UH, got my bachelor's and master's degree here, and then I went on to office in Monterey, California. That's kind of where I got my first taste of fire weather, and then moved back here pretty quickly in 2003 and have been here ever since. The picture there is one of those times I was fortunate to be out at Crater Lake on a fire, and I promise you I wasn't sightseeing. The fire was literally right in front of me on the other side. It was just a bonus to be able to be there and look over my shoulder and see that. See if, sorry. You see
Yeah,
if
we
everyone can
just
hear.
yeah. Is anyone here? We just got a note from Cindy that says we lost audio. Let me try to get this back
Yeah.
on. Is anyone else having an issue? We hear you back.
Oh,
Okay, thanks, guys.
great.
We're
Sorry,
back.
sorry about that. So we'll just move on here. I've been here at the National Weather Service since 2003, and I've been doing weather here more or less for quite some time. So what we want to talk about today is sort of the climate and the weather out here, including how that works with fire risk, a little bit about drought and the main driver of that, sort of the influence of temperature and wind and relative humidity out here, and sort of the challenges that come along with that, and how we sort of communicate high fire risk and what we look at, what the thresholds are, and then a little bit about resources. As far as climate goes, you'll see there that's sort of a herky-jerky animation of a month's worth of sea surface temperatures from satellite across the Pacific. And that big ocean out there is the main driver in our climate. We're sitting out here in quite a long ways from any landmass, so the ocean is the real controller of our climate. And it's one thing about the ocean temperatures, as you can see there, aside from the little herky-jerkiness, the overall picture doesn't really change. That's a month's worth of sea surface temperatures, and things don't really move all that quickly with the ocean. And so that's a real modifier of the climate out here. That's why you don't see wild swings in temperature in Hawaii, simply because we have this massive ocean around us modifying things. One of the things it also does is that due to global circulation patterns, you tend to get these areas of high pressure in similar latitudes around the planet. And that one tends to set up to the north of us. That's our beneficial trade wind generating high pressure system. It's called the subtropical high. And it sits out there for a good portion of the year. And in other parts of the planet, too, that have a climate that's fairly similar to Hawaii, you're going to see more or less the same setup. Here's an animation of a month's worth of July weather maps that we did, and you can see those blue H's, that one that kind of stays to the north of us. It kind of gets beat up every once in a while, and it pops back to the north of us. It kind of meanders around, but more or less, it's tough to move that thing out of place. If you look off to the southeast of Hawaii, you'll see a whole series of tropical storms forming and dying out there, and that's what we don't like to see in the summer, but that's a normal thing, and a lot of times they end up dissipating before they reach here. We've been really lucky this year. It's been much different from years past. So that's a good thing. That's the main disruptor to the trade winds in the summer. But as you can see, the trade winds, they're there all the time. Taking a look at my old textbook, I kind of grabbed this from an old textbook back when we used to use black and white pictures, which really got the point across nicely. Those are called streamlines, and you can see those arrows on the streamlines. You can see it spiraling out of where the high pressure would be located to the north of Hawaii. And comes around us and comes out of the east-northeast and moves more or less in a westerly direction across the islands. And there it is. This is what your typical summertime pattern looks like in Hawaii. That's the trade winds. It's observed 90% of the time in the summer. It's really a fixture out here. Once you get into the winter, this would be the January look. We still have dominant trade wind pattern. It's observed about half the time. But as you can see, that little area with the crisscross sort of in the wind flow to the north of us, that's sort of the disruption when you get some disruption. The trade winds fronts come down. That's when we'll get some weather once in a while. But the high pressure bounces back, and the trades are with us about half the time in the winter. So for the good portion of the year, trades are king. One of the things that you have to realize about high pressure is that on a large scale, the air is sinking, and then it's spreading out, and it spins out in that clockwise pattern. So anytime you have sinking, that tends to make things more stable. And that's when you hear about an inversion. That creates a temperature inversion. That's a stabilizing feature. One of the things that you see out here is that we have that great modifying effect of the ocean. So we're not completely dry, but in a lot of places, that's what they look like. A lot of the great deserts in the world, they're under the influence of that subtropical high pressure and that subsidence. Thankfully for us, we've got that big ocean around us as a moisture source that saves us from looking like that. That said, we still do have some areas where we have but we have some sort of a desert sort of climate. And those two pictures really, juxtapose very closely in terms of geography. You can have lush tropical rainforest with waterfalls, and 30 miles away you can be in a desert. So we have this on the island simply because of one thing only, and that's our geography, our terrain, our mountains. Without that, we would probably be closer to a desert than anything else. So that geography plays a major role in our climate. And not just the rainfall, but also the wind, even the temperature and humidity out here. All is driven by the geography. As you all know, from spending time in the island, some places you get absolute acceleration. If you live on Maui, Kahului, you get blown away every day. If you take a trip towards Maalae Bay there and the southern part of that isthmus right there, McGregor Point, the wind is fantastic. It blows like crazy, and there's a whole line of windmills along one of those ridge lines. It's a tremendously windy place. If you go just to the western slope of Haleakala sitting there, you get this weak return flow that sometimes it blows opposite as the trade wind. So it's tremendously varied what you can get here, just with the terrain sitting in the way, almost like the rock in the stream, sort of deviating the flow. And one of those big schematic of something like that is you can get a large obstacle. In this case, we all know would be the Big Island, where you can completely block the flow, and you'll get sort of return flow that goes the opposite way. You get these eddies that make the wind blow in the opposite direction, and that's pretty much what happens on the Kona side of the Big Island all the time. So the terrain effects are really important on here. It's a really important thing to keep in mind. You end up with this sort of map. This, I believe, HECO did this when they were looking at where to set up wind resources. And anything that's orange into the hot color, you can see that's your windy areas in your typical trade wind flow. This is a map for background, probably 15 knot trade wind flow. And we all, just if you've lived here any amount of time, you know where those places are, and it's all due to the topography. So the wind is being squeezed between two islands. It's being accelerated in some places. It's being completely blocked, and that's a big driver of everything. Now, where the wind can sort of push things up, there's this term called orographic precipitation. As people know, the higher up you go in the atmosphere, the cooler it gets. Well, if air is forced up over an obstacle, in this case the mountains, you can start getting rainfall. And as we all know, the windward sides of the islands are quite wet because of this process that goes on. But on the flip side, once the wind makes it across to the other side, you get a rain shadow. So you have these two competing phenomena that go hand in hand, that create this sort of situation. The numbers might be hard to see, but you can go from what is some people call the wettest place on earth at Waialeale is, you're talking nearly 400 inches of rain a year, and down on the slopes down by Kekaha on the west side, you're barely talking 20 inches. So there's tremendous variation. You see it on every island. And it looks like the cutoff or so from what we see during a lot of the fire activity is Clay and I were talking about it the other day. It was like, it seems like this 1,200 millimeters, around 45 to 50 inches, seems to be the cutoff as to where places tend to become fire prone, or at least have an active fire season. And you see that on every island. Every island has it, some to a greater degree than others. And it all has to do with how that flow is being channeled around the islands and where some of those shadows are. The Big Island is probably the starkest example. If you're Kauai, you're talking 10 inches of rain. And on the other side, you're up close to 300. So it's an amazing effect how that happens. It's really incredible. And I went back to my old textbook, and this one's kind of a funky way of showing it to you. And just to show one thing, it's like I've got Hilo, Honolulu, and Johnston Island there, and all those lines that represent the amount of rain they get in a given month. And Hilo just is amazing how much more rain it gets than Honolulu, because obviously it sits on the windward side. But one thing you have to note is little old Johnston Island, 700 miles off to the west-southwest of us. It looks a heck of a lot like Honolulu, and there's zero terrain on Johnston. It's a flat atoll. So to think about it in another sense, if our terrain wasn't here, the whole state would look a heck of a lot like Johnston and Honolulu. We would not have the vegetation and the rainfall that we have. So it's really an incredible driver. One of the other things too is the schematic here. This would be sort of my attempt to show what goes on Maui. I grabbed one out of the textbooks that unfortunately had snow on it, and Haleakala only has snow on it like once every 3 years. But
They do have pine trees there, though.
They do have pine trees, so it sort of works. It's beside the point. But the schematic can show one thing, in that if you're on the windward side, near Hana, you have this moist air mass that comes in from the Pacific. I have a temperature of 81. Typical humidity, if it's 68% humidity, I took a normal dew point, 68% humidity. You force that up the mountain of Haleakala. By the time you get to the ranger station there, at about 7,000 feet, the air would have naturally cooled to around the mid-60s, and that's due to natural processes that go on. But one of the things that people don't think about is there's a different process that goes on the other side of the mountain. If the air can make it over the mountain and then gets forced down the slope, there's a different process that goes on. The air actually gets compressed, and it warms, and you get a drying effect. And also, you can naturally explain a lot of the variability on the islands just by this. So Hana could be low 80s and a 70% humidity, and over in Makena, you're talking upper 80s and RH is below 50%. And that is solely due to the fact that the flow is being forced over, raining somewhat, and then just coming back down the slope. So it's all tied into our climatology here. So to go in there and just steal sort of a schematic out of some of the Atlas of Hawaii there, and it's just looking for different parameters. And this is something we never use as meteorologists, but it's mean annual available soil moisture. But man, it really shows you where all those oranges and reds are. It ties in perfectly to the climate. So there's very low soil moisture there. And we know what that means. It's drier climate. And it also ties in on the right is where the areas that we typically would warn for during a critical fire weather event. It ties in quite nicely as to where all those places are. Now, there's definitely some variability. I mean, climate's not what you see every day. You have natural variability in the weather. And most people think of weather, of course, especially if they're from the mainland, they think of 4 seasons. But here, we're really down to 2. The Hawaiians identified 2 dominant seasons, one they call Ho'oilo, which is more like winter. That's when I was showing you how when the trade winds get disrupted, it tends to be cooler, wetter. And the trade winds aren't as strong. Here's sort of another thing out of the Atlas in January. These oranges and reds places on the islands tend to get somewhere around, in the month of January, 3 to 6 inches of rainfall in those leeward areas. The other season that the Hawaiians identified as Kau more or less lines up with your summer months. It's warm, steady trade winds, and it's dry. Taking a look at the same map, unfortunately, they use the same scale, but here, oranges and reds are less than 3 inches. So half the rainfall. In a lot of places, you're talking maybe a quarter of the rainfall that you get. So there's an incredible difference in the amount of rain that you're going to see from winter to summer. And that's important, especially since the summer months here, like I said, they're drier, they're definitely hotter, and the trade winds are steady. So it's the windiest time of year too. So that all tied together ties into where you see the highest fire danger. And it's across the leeward areas, as everyone knows, but that's definitely tied into our climate, since that's where you get the least amount of moisture. The fuels tend to be grasses and shrubs. They're flashy, they dry out quickly. So that's the fire-prone area. So it all ties in quite nicely with what we know about the climate. And of course, there's also some variability that man, we just went through a stretch in the past few years that was kind of touchy when it comes to some of the effects of El Nino, but somehow we get out of it unscathed, which I'm still surprised by. I can't believe it. But one of the things you usually see with El Nino is that summertime, that dry season, is usually wet. And that makes sense because as the El Nino matures, you get active hurricane season, there's more moisture around, the trades are weaker, we tend to get a lot really uncomfortable around here, humid, a lot of showers, and especially if you get a tropical system comes over us, a lot of wet events. Because of that, fire activity suppressed. We saw that with the last strong El Nino. After the El Nino weakens, heading into the summer months, actually heading into the winter months, when the El Nino starts to weaken, you get drought development. And essentially, our wet season shuts down, and we start developing drought. And a lot of times, the drought that develops in Hawaii is oftentimes tied with El Nino. It can happen naturally, but a lot of times your stronger drought events are going to be tied to El Nino. And when that happens, you can pretty much throw away what we know about when fires are supposed to happen. They can start happening at any time because, like I said, we tend to have a lot of finer, flashy fuels. It doesn't take that long for them to dry out. And once you start to get rid of El Nino as it winds down, that's into the following summer. I stole this graph from some of Clay's work. It's you tend to get an early and active fire season. In this graph, the farther on the right and the higher up you go, so the farther right and towards the top, that means that's a stronger El Nino and the more acreage burned in that year. And all those years in that red box are El Nino years. So it correlates quite nicely. The last El Nino we had didn't quite work out like a textbook. We feared that it was going to be a really active fire season and we were bracing ourselves, but it didn't weaken as quickly as we thought. It was a monster. It was up there in the top 3 events that we've witnessed. So it hung in there longer. The tropical season hung in there, so it actually suppressed the fire activity. We kind of came out of that unscathed too. So we dodged 2 bullets really with that last strong El Nino by not getting hit by a strong tropical system. People in the Big Island would beg to differ. The Windward Big Island did get impacted, but it could have been a lot worse. And the fire season turned out not to be as active as we had feared, simply because the El Nino effects lingered. So that was nice. So when we talk about fire weather, when we were talking about doing this, the question came up is, what is fire weather? And I never really thought about it. And I never really stopped to think about what that means to a layman. And it's a relevant question. People always go back to the fire triangle when they're talking about wildfire and the components of it. You have fuel, oxygen, and heat. And really weather plays an important role in all 3 of those. The fuels are affected by the weather and how they dry out. Oxygen, obviously, if you have a windy condition, you're oxygenating. You're bringing in more air, fanning the fire, so to speak. And of course, at hotter days, with the hotter days of summer, you're bringing in more heat that's available to dry the fuels out. So weather's it's really important. So what we look for when we're talking about critical fire weather is almost what from a meteorologist standpoint, we're thinking of the critical conditions, like when are things going to be, when it's that combination of dry fuels and weather that's going to support high fire danger or extreme fire behavior. So that's what we're looking at. And it's most likely going to happen on those hottest, driest, and windiest days that I was talking about that are tied into our climate. And that's going to be during your strong, dry summer trade wind events. Now, what we want to do with the Weather Service is that the whole purpose is that we can get the information out to the people who need it the most, and that's the land managers and the firefighters, because they're going to need to know in terms of resource management or even protection of life and property as to if there's that really high risk of widespread new starts or control problems with the existing fires that they have on the ground already. So that's what it's all about, our watch warning program. So, watch goes out from more or less 24 to 4 days, and a warning is more or less imminent. Usually we'll issue it more like a day out and for something that's imminent. So like we said, there's components to this. There has to be a weather component, but there's also, you can have dry conditions, but if the fuels are wet, then it really doesn't matter. So there's the fuel component. And that was one of the things that when I first developed the program, it was one of those things we struggled with at first. We settled on this Keach-Byram drought index, and it was developed in a more or less humid climate in the southeastern United States, and it was a fire index. So we started looking at it, and it ranges from 0 when it's wet into 800 when it's extremely dry, and it changes daily based on maximum temperature and rainfall. Fortunately, one of the guys over at the UH meteorology department had been doing some research. It was literally by chance that this was going on, and I knew this gentleman, Klaus Dalling, who was doing the study. So all I had to do was go downstairs and talk to him. So it was a real stroke of luck. And he had told me that he found a strong relationship between this KBDI and fire activity in Hawaii, both in the number of fires that you're going to get and the number of acres that burn when you have certain thresholds. So it was really fortunate that we found this. And he found that the driest leeward stations on each island can serve as sort of a reference point when you look at the weather. and that should reflect your fire activity. So the drier these stations are, it's probably going to be a good proxy to tell you what's going on in terms of the fire world. So he used the stations that he used were all the driest ones on each island, Kekaha and Kauai. The HNL is the airport here on Oahu, Lahaina, and Naalehu. So we just focused on Honolulu, since unfortunately a lot of these stations in Hawaii, a lot of stations that we use are either airports or they're tied to looking at rainfall for flooding events, and they're not really tied into dry places so we can monitor rainfall there. Although we do have some, and out of the best sites that we could find, Honolulu was the one that was the most reliable. If it broke, the thing was going to get fixed right away, and we could really count on that data being there. Some of these other places we weren't even getting live data from. So it's to do things in real time. The decision was made to go with Honolulu, and I crunched some numbers, and you can see that we found a threshold of 600 seems to correlate quite well with fire activity in Hawaii in terms of the things getting critical, and that tends to happen as you head towards the peak of the fire season, sometime in late July, maybe early August. That we tend to see the KBDI go over 600, and it usually stay there and into the next more or less few weeks in this time frame into early October is what it usually does. So the peak of fire season, the KBDI seemed like it worked fairly well and is a good trackable index. That was actually the easy part. Now, one of the problems here in the tropics is that we have low variability. As I mentioned before, we're in this middle of this vast tropical or subtropical ocean where the temperatures don't change a whole lot. I have two temperature traces on there. One's from Honolulu, the gray and the yellow lines are the Honolulu maximum minimum temperatures. And you can see they're pretty darn flat throughout the year. The entire year, you're only going to get 5 degrees or so of temperature change on average, from your average high in the summer to the average high in the winter. It's a really narrow range. And for whatever reason, I chose Missoula because I was there in a fire last month. So I just chose that one because that one shows you quite nicely how their high temperatures during the peak of the summer there are pretty close to ours. And, look at the wide range of temperatures they get. And I remember waking up in my tent on many a night when it was 40 to 45 degrees in the morning. So they get a massive temperature swing there. And during the year, they get massive temperature swings. So they get a lot more variability. We don't. That's a big challenge for us here in trying to determine these thresholds as to when are the critical days. And also, you don't have to know what this means, but what you can tell by looking at it is that all those bars are sticking out off to the northeast quadrant there, and that thing's called the wind rows. This is roughly 30 years or so of Honolulu International Airport wind data, and that just represents a northeast wind. It's pointing to that quadrant. So the wind in the summertime, in this case I chose July, it just consistently blows out of the northeast all summer long, and it just does it with very little variation. All the other directions would be represented if they had little spikes on the other side, and they're teeny tiny little observation points. So we get this steady trade winds all the time in the summer, and we don't get a lot of variability. So we have to pick out this signal from a really difficult sort of a flat field. And sorry to throw a table at you, but it's one of the things I lined up here. This is from the airport, just tracking. The KBDI changes a lot through the year on average. This is the average numbers that you'd see over a 30-year period. So for July to January, the KBDI, this is a pretty strong signal. It's drier in the summer and it shows up. But man, the mean minimum relative humidity that you get every day, you're talking upper 40s to maybe mid 50s. That's the difference. So winter day drops into the mid 50s RH. Summer day, it's usually upper 40s. But that is not a very large swing that you see. And the wind is even worse. Looking over there, the winds change very little throughout the year in terms of the maximum wind that you see. So it creates a challenge. But we're able to kind of crunch the numbers and get through things and come up with a suitable criteria, and that was 45% relative humidity and a wind around 20 miles per hour or more. And that only happened on 5% of the days when both of those things happened in this large database that we use for 25 years. So when we couple that with some of the, that's about 17 days a year. Then we couple that with the KBDI information for KBDI over a certain threshold. That's how we targeted the high fire danger days. So as we got into the high KBDI of 600, relative humidity down around 45% or less, wind speed around 20. These 45 might seem laughable if you're from some other location as to terms of dryness, but it's a fairly dry number here. Very rarely will drop you below 40% at sea level. Those criteria, they're on average, they're only met 4 days a year. And some that they're distributed unevenly, meaning that some years you don't have any events and some years you have a whole bunch, but on average it's 4 days per year in that sample. And what that, to boil it down to something, is that only a small departure, 5 to 15% change from normal conditions here in Hawaii, it's a big deal, especially in the summer. That is the difference between normal trade wind day that we saw this week and critical fire weather conditions. When the trades blew fairly strongly late last week, we were borderline. And then by yesterday, we're down to more or less average. You probably didn't notice much of a difference looking out the window, but that's what we're up against here, and that's the reality. I mean, there is a challenge that we're only using this one station to diagnose what's going on. The airport is just one site, and the terrain and the conditions out there are varied, but what goes on at Honolulu can be sort of a proxy as to what the conditions are out there. And I've talked with Clay. He's done some informal research, and it seems to work fairly well. What's going on right now? I put a picture of the drought index, the drought monitor that recently went out, and you can see that there's quite, for those of you familiar with it, there's quite a bit of drought classification out there, and the island of Oahu is sort of in the nicest position. It actually has the least amount out of everyone. And on the left, that's a trace of KBDI, and that the zigzaggy line, the blue line, it is tracing Honolulu KBDI, and that KBDI number, it makes sense with the conditions on Oahu, but I'll admit it's a weakness, and the weakness shows up right now that the other islands are experiencing worse drought than we are, and the KBDI is a bit lacking to reflect that. So that's something that we need to address in the future, is to try to expand this and come up with a better way of doing it. But for the most part, it works out quite well. But fortunately or unfortunately for me today, I can show you an example where it's not quite so nice. I mean, I have taken a look at some of the trends from the other islands, some of the other stations out there that I can rely on. There's very few. Unfortunately, they're going to be not so perfect sites because I need the data in real time, and I need a site that's going to be fixed right away. And so it's kind of funny that I've got the airports. Kahului, most people don't think of it as leeward, but it sort of behaves that way, and I think I can use that. Same with Lihue, oddly enough. That whole area near Wailua and down near Lihue, it's kind of dry. It's not as windward as most people think, and it's not perfect, but it could probably be fit in there somehow. And the airport at Kaunakakai works quite nice, actually. I think that one will fit in really nicely with the data I get out of Honolulu. Of course, all those places are going to have different terrain effects. They're going to have a different wind and different RH as Honolulu does at the same time. So it's kind of a bit of a challenge there. In terms of capability, I wish you were all in my office right now so we could show you a little bit of a tour as to what I look at on a daily basis. Here's just sort of a snapshot of I've got model data on there. That's how we use several models to diagnose what's going on. The other side is satellite data. One's just a regular infrared image, and other ones are a precipitable water image that comes out. It's things that we track in terms of how to measure humidity and how to predict what's going on. We're using a lot of information to try to really figure out that narrow 5 to 15% difference that it takes to get critical fire weather conditions. And it's a challenge, but it can be done. We do it. Here's sort of a zoom back view. That would be one of my screens, and there's actually 4, and then I have a PC also. So I mean, I'm sort of inundated by data every day, and which is it's really cool, but it's kind of gives me no excuse. I got to get that answer. So how do we get this, once we do figure out what's going on, how do we get it out? And then there's different ways for us to communicate risk. Of course, we have our routine products, which are, I have a fire weather planning forecast, your traditional typed out thing with a little short discussion, and then your parameters for different zones out there. One of the things I would recommend, if you have any interest in sort of getting any insight as to what's going on in the head of the forecaster, is to read the area forecast discussion that comes out from not just my office, but any office really. Everybody issues them, and it'll tell you what they're thinking. And a lot of times they'll be more candid about uncertainty in there. So that's kind of a nice place to glean information, is from the area forecast discussions. You can find those on the websites. But what we really want to do is, when it gets important, is we want to issue those watches and warnings. So that's our goal. That's our mission for the Weather Service, actually, is not the day-to-day weather so much. It is protection of life and property through the issuance of watches, warnings, and advisories. So the Fire Weather Watch and Red Flag Warning, and once again, it's another text product that we issue. The proper civil defense organizations, government, land management, they're going to get notified of this. Once we send it out, the state has means of distributing this information. So they're going to get notified through that route. Another way I also mentioned is through the webpage. You can go on our webpage, and there's always a map with the warnings, the legends on the left. It can be kind of overwhelming if you've never been there, but because there's a whole lot of options there, but you can spend some time in going through there and looking at some of the forecasts we have, and I'd be happy to help someone out looking there. Unfortunately, to my knowledge, all the subscription services on mobile devices that are out there are not governmental. We don't have one that I don't think that we can issue to the general public. I can sign up for stuff since I'm in the government, but I don't think anyone else can. So you're stuck with what your provider decides to send you out, and there's no guarantee that a red flag warning is going to be pushed out as a notification on your phone. I don't think it is. I'd have to double check. We do have a presence on Facebook and Twitter as well. So there are social media outlets that we're sending out things to. Now, as far as resources that you can look at too, fortunately, I'm tied to, I've heard different things, but a lot of people tell me that I'm not allowed to go outside the government. So I'm just going to stick with the government here, even though there's a lot of really cool stuff outside. We do have a fire weather section on our webpage. You go there. You can access our fire weather forecast there as well. I have a plot of the KBDI at Honolulu's there. One of the cool things you can get too, if you don't like the traditional weather forecast up top, it has sort of a point forecast. So if you got to know your latitude and longitude, there's a more complex way to get to this information. But if you're able to find your latitude and longitude, you can choose what you want to get, and you can change it. You can get a graphical display like this through time of all the weather parameters: temperature, dew point, humidity, precipitation chances, wind, things like that. And that could be a nice tool for you to use for planning purposes. And also, if you don't like that, maybe you prefer to have tables of numbers. I don't know why, but if you did, you could get the same information in a tabular format. So that's out there as well too. Another great source for information is, obviously, Hawaii is part of the Northern California Geographic Area Coordination Center. When it comes to predictive services and fire weather, we're part of the called Northern California GAC, and through that, they issue a monthly and seasonal outlook too. So that's some great information that comes out of there in terms of fire danger. And then we're talking, the land managers are talking to the people that produce this, so it's getting sort of the opinions of the people on the ground. And of course, I always look at the drop monitor too. A lot of you are out there. Our hydrologist in the office in Honolulu does a tremendous job with this, and talks to a lot of people on the ground. It's not just crunching data. It's getting the farmers and the ranchers, input on what's going on. So that's, if you don't look at that, you really should. So it really wraps it up for me in terms of what basics, what we're looking at in terms of climate. And it's like, And I hope I helped you understand why Hawaii's climate is the way it is. And we're sitting out in this ocean, and it's really our terrain that is the driver of everything. And the more you can, when you look out and you go somewhere and you understand where the terrain is situated and where you are with respect to the trade winds, it really helps you understand right away as to what the climate is where you are on the islands. It all makes sense that way. And where the highest fire danger is tied in. And of course, always remember those hottest and driest days that we're trying to target. But there's always that challenge out there of that low variability due to our position in the tropics that creates an extra challenge. I mean, I hope you learned something. Thank you for having me. If there's my contact information, that's the general office number where you can get in touch with a human being, and there's my email as well. And of course, feel free to contact me with any questions, or even if you want to stop by. We're right there in that picture. That was the fire up at Waihila Ridge, and we're right next to that blue building in the upper right corner on campus. And we welcome visitors. You're welcome to drop by anytime, and I can show you a little bit about how we operate. And with that, I'll turn it over to you folks to see if you have any questions.
Great, thanks a lot, Derek. Yeah, just like Derek said, if anyone has questions, we're happy to moderate them here, and we can make sure you get heard, and maybe we can answer them, hopefully.
You should.
Yeah. So again, you can use the question pane there, or you can raise your hand and I can unmute your mic. So yeah, shoot. So anyone with questions? Okay, first question from Don Bruins asks, so are we going to have a normal wet winter? Derek?
Okay, good question. Long lead stuff is always challenging, but as you can see, there was a little bit of uncertainty earlier in the year with in terms of what has been going on with El Nino, and that's usually the main driver of anything from normal. Everything looks like normal with a slight chance of La Nina, so there's not really a strong signal out there. So when there's not really a strong signal out there, I go back to my safe place, which is expect normal. And that's the best I would think right now. So equal chances, probably a normal time. I mean, it doesn't look like there's any El Nino. El Nino development is not really an option. So that leaves us with probably more or less normal.
And I apologize, Kaylin Silva asked, are there any particular flashy fuels that was higher potential for burning? And I apologize, you asked that about 20 minutes ago. And, well, I can answer. I mean, there are certain grass, but pretty much the grassy fuels that you see in the lowland areas, around developed areas, old ag fields, they're all pretty high potential to burning. And our ability to kind of identify, like as Derek was saying, those exact conditions and relative humidity, when they're going to be cured, and the drought is, we haven't got that fine-tuned quite there, but yeah, they all present problems. And we've got, they cover quite a large extent of the state, so about a million acres of those flashy fuels. So any other questions? Well, we've got Derek here. Again, you feel free to use the chat window for questions, or I can also, you can raise your hand and I have the mic controls here. Let me just double check I'm not missing anybody. Okay, another question. Randall Chang, do periods of Kona winds impact during the fire season?
Oh yeah, absolutely. If the El Nino summer, when we had that back in 2016 or 2015, it's a great example of how that's strongly tied in. It's when you get an El Nino developing like that, you get more events like a Kona wind event, essentially disruption to the trade winds, really all it is. And when that happens, you tend to get more southerly winds. Southerly winds are usually lighter, and they're usually much higher humidity coming out of the deep tropics. So your odds of seeing anything getting relative humidity values down into the 40s really just drops right off the table. You're just not going to get it when you get deep southerly flow or any real disruption to the trade wind. So absolutely. And since we don't have any strong winds that are dry, it also that actually adds a desiccating effect. It dries things out, and you tend in Hawaii, a lot of the fires that are large tend to be wind driven. So Kona winds tend to be lighter and more humid. So you're really knocking down the fire danger, and you just won't get a big fire going when you have an extended run of Kona winds.
All right, another question from Pablo Beimler. Hang on, Pablo, just to expand this. I've been hearing from some researchers and even from on-the-ground observations. Okay, here we go. This is a long one. Bear with me here. So I've been hearing from some researchers and even on-the-ground observations that the prevailing trade wind patterns have been fluctuating a lot more recently, likely tied with climate change. How grounded is this in some of the work you're doing, and what are the mechanisms that may be changing these dynamics? Good question.
Yeah, that's a good one, Pablo. Putting me on the spot for that. No, I'm just kidding. It's yeah, I've seen the research come out from University of Hawaii. I've seen a couple of interesting things from the meteorology department that the trade winds are tend to be weaker, and with that, we're all still we're scratching our heads trying to figure out what that will mean for us. When the trade winds are weaker, yet I've seen some other stuff. I believe I don't know if it was John Beluga's group that came out and was saying that the inversion was getting stronger and lower, which, man, that's a really interesting development. So if the oceans become any warmer, you'd expect there to be more humidity, more moisture in the air, and you'd expect that to kind of pound on the inversion and lift it a little bit. But he's finding the opposite, and that would make sense with weaker trade winds that you tend to see sort of warmer conditions around here. So I don't have a good answer for that. It's like, I think in my envisioning of things, a weaker trade wind pattern around here with a warmer ocean, that would point me towards a more humid climate. And that would take me, my simple mind tells me that's a lower fire danger. It's probably not going to work out that way. So it's a difficult question to answer. But since the trade winds, we're going to lose a lot of water on the windward side. Maybe that'll mean an expansion of the area where you get fire activity. It's hard to say. That's a good question. Thanks.
Good answer too, I have to say. Thanks, Derek. Any other folks? Let me just scan through the list here. Anyone else while we've got Derek in the office? We were kind of joking yesterday or the other day that we were like, I wonder what the climate change question is going to be. But thanks for that, Bob.
Yeah, no, it's not too bad.
But it just goes into the complexity of the different factors that are driving fire risk in the state. Kind of conflict between the potential drought expansion or dry area expansion and then the winds, which would be more fueling like when a fire is actually burning. Well, if there's no other questions, yeah, I think we'll wrap things up. Oh, we do. Never mind. We got one. Can we get copies of your slides? Very helpful presentation from Randall Chang. Yeah, well, we can post those on pfx.org. We will also post a recording of this webinar if you want to share with folks or watch it again. And all that will be available on the website. What is the economic cost of fires in Hawaii? Kaylin Silva, $1 million question. Yeah, we've actually been working on that a bit with Kim Burnett at the University of Hawaii, the Economic Research Organization. And it's a tough one, right? Because you can actually quantify suppression costs pretty easily. But the cost, well, I'll put it to you. What's the value of an acre of native forest, for example? Those kinds of questions are a little bit difficult to quantify. And we've been looking at some different approaches to get at that. But yeah, I think those sorts of questions actually are relevant not to just fire, but other sort of natural resource issues as well. And if you're really interested actually in that, I know that DOFA, the Division of Forestry and Wildlife, does have a table that actually gives the value of different types of land use, land covers per acre. But we're even with those guys, folks there, we've been talking about trying to figure out. No one really knows where it came from and how what those numbers actually mean. So it's a challenge to quantify the damage caused by these incidents. Any other questions? Keep them coming. If we're willing to keep chatting. If you guys have other things. Yeah, thanks for the thank yous too that are coming in. Appreciate it. All right. Well, I think with that, if there's no specific questions, we're going to wrap things up here. Again, I think when you guys close out the survey, it should send you a link to a little survey. Please fill it out and help us out so we can, keep these things going and show that they are meaningful to you folks. All right. With that, thanks, Derek, for sitting in the office with me, and thanks for everyone for signing up.
Thanks, everyone.
Cool. All right, everybody. Signing out.